Everybody there? I'm going to put the link in one more time into the chat. All right. Okay. So, first question is, and you guys saw, I don't like the way that's looking. Should I make that better? I don't know if that actually makes that better. All right. What famous scientist wrote to FDR about the Germans creating an atomic bomb? Oppenheimer, Isidore Rabbi, Einstein, which, if you remember from the documentary I told you. Who? All right. Atomic bomb. I made one of the great mistakes in my life when I signed that letter to President Roosevelt recommending that atomic bombs be made, but there was some justification, the danger that the Germans would make them. Albert Einstein, one of the most famous scientists of all time, escaped Nazi Germany by coming to the United States. Einstein was Jewish. He'd been working on the theories of creating an atomic bomb and was very aware of the German interest in creating such a weapon. On August 2nd, 1939, Einstein wrote to President Franklin D. Roosevelt. Einstein was not alone. Other scientists expressed their concerns to the president. Specifically, they said that Nazi Germany was attempting to purify uranium-235. Or 235. After that, the government began a project that would change the war. They called it the Manhattan Project, with the goal being to beat Germany in the creation of the atomic bomb. This is big for technology, like back then too, was to kind of get it before the other one has it. So for number one, it's Einstein. All right. To create the bomb, they needed uranium blank the most. Getting uranium. To create the chain reaction necessary to make the bomb go boom, scientists would need a lot of enriched uranium. At the time, uranium-235 was hard to, or 235 was hard to extract. Also, some chemical reactions could not extract the uranium or either. It could only be done using mechanical methods. A laboratory plant was constructed at Oak Ridge, Tennessee. They worked on the method, which included gaseous diffusion and magnetic separation of isotopes. Afterward, a gas centrifuge was used to separate uranium-235 and uranium-238, the useless element in this case, so that they could only have the uranium-235. Once all these fancy procedures were done, the final piece was putting the entire concept behind atomic fission, splitting the atom to the test. All right, so I do believe 235 would be the answer. Weapons grade highly enriched uranium is enriched to blank %. Let me double check too. Natural uranium is, this is what we're looking at over here. So sometimes you got to pay attention to the picture. So natural uranium is, okay, the 238 is 99.2 and 235 is 0.72%, so super low. Low enriched uranium is 3 to 4%, and highly enriched uranium weapons grade is 90%. So number 3 is 90. All right. The project to create the atomic bomb in the U.S. was called this was Manhattan Project. Does it talk about it again? Is that why? From 1939 to 1945, over $2 billion was spent on the Manhattan Project. I would make sure to maybe copy and paste this because of the potential for spelling it wrong. So Manhattan Project. Formulas were created and would see success by the end of the project. One of the most important and memorable scientists was Robert Oppenheimer, who oversaw the project from beginning to end. All right, so Oppenheimer, I'm going to go back and get that. All right, so number 5, Oppenheimer. All right, question 6. The bomb dropped on Hiroshima was called Little Boy. And again, you can say, well, I say Hiroshima, but you'll hear it said Hiroshima or Hiroshima. Hiroshima is a little bit more like the Japanese would say it. They put a little less emphasis on each of it. It's almost like you don't hear an emphasis, like how I say Hiroshima when people go Hiroshima, like they almost don't put any on there at all. All right. Okay, so we're here. So that's how that guy looked. Here's the facility that they were working in. Testing. All right. The gadget, its code name, was tested at 5:29 and 45 seconds Mountain War Time on July 16, 1945. The gadget entered in the atomic age as it exploded in a white blaze. The light turned orange as the atomic fireball began shooting upwards at 360 feet per second, reddening and pulsing as it cooled. The characteristic mushroom cloud of radioactive vapor materialized at 30,000 feet. Fragments of jade green radioactive glass were left on the ground from the heat of the reaction. People from a faraway neighboring community saw the flash. Robert Oppenheimer quoted a remembered fragment from the Bhagavad Gita. I become death, the destroyer of worlds. I did edit this a little bit so it makes more sense. Isidore Rabbi felt that the equilibrium in nature had been upset, as if humankind had become a threat to the world it inhabited. After seeing the results, several people signed petitions against dropping the atomic bomb. Their protest would not be acknowledged. I mean, Harry Truman did. It was a hard decision for him to make, and they definitely put a lot of the obviously the information down, but it was all about, he wanted to save lives essentially. But yeah, all right. Hiroshima, and here's the one that got dropped on Hiroshima. The first time the atomic bomb was used in warfare was at Hiroshima. The bomb was nicknamed Little Boy and was dropped on Hiroshima on August 6, 1945. Group 0 was set at 1,980 feet, and a bridge was the target. The bomb was dropped from the Enola Gay. It missed the exact target by only 800 feet. Impressive for planes at the time. At 8:16, 66,000 people were killed and 69,000 were injured by the explosion. So, true for number 6. The Japanese surrendered immediately after dropping the bomb on Hiroshima. So, after watching the documentary, you guys should know the answer to that. All right, here's the Nagasaki bomb. So it looks a little different. Despite the damage and death at Hiroshima, the Japanese did not surrender. On August 9th, 1945, another bomb was dropped on Nagasaki. This time, a plutonium bomb named Fat Man was used. Fat Man missed the target by 1.5 miles, but it still leveled nearly half the city. Nagasaki's population dropped from 422,000 to 383,000. Over 25,000 people were injured. So, false for number 7. The bomb dropped on Nagasaki was called Fat Man. That's true. Now, I'm going to go up. All right. Let's see. Cross-section, sphere, numbers indicate quantity. So this is the inside, essentially, of how this kind of works. And so detonators. So there's detonators in here. These are the detonators. Component B of outer lens. So I'm guessing this is some of the chemical. Cone-shaped tall component of outer lens. So more stuff. Trapdoor there. Here's the plutonium. Plutonium-239 hemispheres are right in here. So each side of this red. And the thing that makes the explosion is the splitting of an atom, I do believe. Oh, here we go. Yes, how it works. That's what we want. All right, so number 1, we're going to watch this guy right quick. This is kind of the showing of how it was dropped.
Never sat on a bomber this long over Germany. Like a blasted SS scout. Yeah. He said, nothing there. No opposition, no help. Just going to bomb target.
So they're just talking about there's nobody around. Nobody's shooting anybody. They're like, normally we wouldn't make it this far. This is a whole this is a clip from a documentary.
I saw an aircraft, like a tiny silver drop, entering the sky above Hiroshima.
This is a survivor.
He recognized it as an American plane, as no Japanese aircraft could fly at that altitude at the time. It was just one plane, so I assumed that it was passing by as usual.
So they did have these kind of flyby kind of things for spying, seeing what they were doing. Another survivor.
I was wiping the desktop. That was when the bomb was dropped.
So that is Little Boy, and they have to try to get out of the way fast. They know how high this thing is kind of supposed to explode from the tests from the Manhattan Project, so they know they need to get out of here. And so there are people who are kind of like, what is that falling down?
45 seconds from the time the bomb left the airplane until it exploded. And I think there wasn't a man in the airplane that wasn't either timing it with his watch or counting or doing something. I was sure the bomb was a dud. I was sure it wasn't going to work.
Yeah, they didn't know if it was going to actually go off or not. They had no idea.
After falling for 43 seconds, the time and barometric triggers started the firing mechanism. A uranium bullet fired down a barrel into a uranium tank.
So this is on a timer, I do believe.
Solid matter began to come apart, releasing untold quantities of energy.
So part of this, it's important that it go off before it makes contact with the ground, so that in a sense it can explode in more spherical manner versus hitting and just going out, so that it causes damage kind of underneath. I'm sorry, it's all like, quality is terrible. Alright, so it gets dropped. Some people, they're gone. Like, they're incinerated immediately. They are gone. So there's that aspect. Then, there's accounts, I think, of like shadows being kind of permanently like on buildings, like the way it went off. You could see somebody's shadow when they were there previously. So there's that. And let's see how this exactly works, because a lot of people don't know. And it is, in a sense, it's complicated, but it's really not that. Like, they'll use a lot of bigger words, but essentially it's not that complicated. Okay, maybe I'm just judging that. Maybe it is super complicated.
At 5:30 a.m., dawn on July 16, 1945, near a small town called Alamogordo, New Mexico, the course of human history was changed. The first atomic bomb was detonated that day and sealed the fate of humanity. It took the work of many people to accomplish this engineering feat, but the principal leader of that Manhattan Project, and the man considered the father of the atomic bomb, was Robert Oppenheimer. After witnessing its awesome power on that fateful day, Oppenheimer was so taken aback, he quoted a verse from the sacred Hindu text, the Bhagavad Gita. Now I am become death, the destroyer of the worlds. We know its awesome power, but how exactly does an atom bomb work? An atom bomb works on the principle that when you break up the nucleus of an atom, a large amount of energy is released. Why? Because it takes a large amount of energy to keep the nucleus bound together. When you split it apart, the energy is released. The analogy is like a stack of bowling pins. When you hit it with a bowling ball, all the energy that you used in stacking them is released. You can think of the nucleus of an atom being similarly stacked together. Physics purists may ding me for this analogy, but for the purposes of simplification, this is a good way to think of it. Scientists chose the biggest, heaviest nucleus that is found in nature to be the best candidate for splitting: uranium. Uranium is unique in that one of its isotopes is the only naturally occurring element on Earth that is capable of sustaining a nuclear fission reaction. A uranium atom has 92 protons and 146 neutrons. Together, they give an atomic mass of 238, U-238. A very small portion of uranium, when it is mined, is in the form of an isotope, U-235. This isotope has the same 92 protons, but only 142 neutrons, or 3 fewer than U-238. U-235 is...
I do believe next year in 8th grade, you guys learn about atoms in detail. So this might make more sense next year. I don't want to spend too long on talking about what is a proton, neutron, and electron. But just think of a atom. Everything is made up of atoms. You, the table, the air, the everything. So these little pieces, and so they're looking for the most dense element in a sense. And it's going to be, because that's going to, if you, let me think about this. If you blow up a feather versus blowing up a rock, there's going to be a difference.
Highly unstable, which makes it highly fissionable or splittable. When uranium U-235 is slammed by a neutron, it becomes uranium-236. U-236 is so unstable that it almost immediately splits into two more stable atoms, krypton and barium. In the process of splitting and creating two more stable atoms, a whole bunch of energy is released, along with 3 more neutrons. These 3 neutrons fly out and slam more U-235 atoms, and thus a chain reaction occurs, causing more and more U-235 to be split and ultimately causing a huge explosion. So what's the big deal? Why don't more countries have the bomb? Well, the problem is that natural uranium contains only 0.7% of this U-235 isotope, and a whole bunch of it is needed to make even one atomic bomb. So mined natural uranium has to be enriched to get U-235. Sometimes this enrichment is done by turning it into a gas and letting the lighter gas flow through a one-way barrier so that it rises to the top, because U-235 is
So it's kind of like filtering.
lighter than U-238. Another engineering challenge is to create a vessel with the correct shape and material to contain the neutrons after fissioning, so that they do not escape but rather cause more atoms to fission. And it is lined with a special mirror so as to force neutrons back into the fissionable material rather than escape the vessel. Then the correct amount of fissionable material has to be placed inside this vessel. This is called a supercritical mass. There has to be enough mass to sustain an uncontrollable chain reaction, resulting in an explosion. And finally, the supercritical mass has to be kept apart until you're ready for an explosion. Otherwise, an explosion can occur.
So imagine like one side is like the bowling pins, right? And this side is the bowling ball. And they have to be separated. Otherwise, the bowling ball is just going to knock over the pins like immediately. And you don't want that to happen until, you say you want it to happen. Otherwise, it'll just like explode immediately. And that would probably suck because then, you wouldn't exist.
When you don't want it. The reason is because these isotopes are unstable and are throwing off neutrons randomly. So the mass has to be kept apart so that it is subcritical until ready to be exploded. In an atom bomb, 2 subcritical masses are slammed together, usually with a conventional bomb contained inside the outer bomb. This conventional explosive charge inside the container initiates the chain reaction to produce your typical mushroom cloud.
So imagine that, like, the human that's throwing the bowling ball is that extra bomb that's kind of like taking the bowling ball and just throwing it and slamming it together.
Where does all that energy come from? It comes from Einstein's famous equation, E equals mc squared, the mass.
And this is why Einstein is kind of like, this is part of the whole atomic bomb process, right? So that's why he was working on this. So he's working on this, right? But part of this is being able to apply this to things like the atomic bomb. I mean, other stuff too. But that's how, one of the reasons he knew.
The material left over from the nuclear bomb is slightly less than before the explosion. Only about 0.1% less. And that 0.1% is what causes that huge explosion. Imagine how big that explosion would be if all the mass, 100%, was converted to energy. We need to thank our lucky stars that although the concept of an atom bomb is simple, the process of actually creating a bomb is not so simple.
And essentially, that's kind of what makes nowadays a country a superpower, is if they have nuclear weapons. This is why you'll see kind of smaller volatile countries wanting an atomic bomb, so they're kind of taken seriously in a sense, right? So we've got North Korea, Iran, these different countries. They want, like, and you can kind of see and watch and be like, hey, how much uranium or plutonium do you have, and what are you doing with it? So that's what we're kind of keeping an eye on most of the time. So that is that one.